Suppose that orders at a restaurant are IID. IID means independent identically distributed random variable. Okay, IID random variable with mean mu is equal to rupees 8 and standard deviation sigma is equal to rupees 2. Estimate the first question, the probability that first 100 customers spend a total of more than rupees 840. Second question, probability of 780 less than sum of 100 random variable x1 plus x2 plus etc x100 is less than or equal to 820. So there are two problems we have to find out from the given data. So this is the problem under central limit theorem because they are given IID random variable, independent identically distributed random variable. From the statement of central limit theorem, the given n random variable will be sequence of independent identically distributed random variable. So that this is the problem under central limit theorem. Okay, so from the problem we have to collect the given data. So the given data mean is rupees 8. So here given mu is equal to rupees 8. So 8. Okay, and sigma is equal to rupees 2. So sigma is equal to 2. Okay, and now here in the central limit theorem, Sn is sum of n random variables. So in this problem also they are given sum of n random variable. There are 100 random variables they are given. So n is equal to 100. So also from the problem we can understand that n value is 100. N value is equal to 100 because there are 100 random variables, sum of 100 random variables. Okay, so n is equal to 100. Okay, in the central limit theorem, Sn follows, here Sn is sum of n random variables, so that you consider or let Sn is equal to x1 plus x2 plus etc xn. The n is 100, so this is sum of n random variables. Okay, and then here the Sn follows normal distribution n of n mu comma sigma root n. Sn follows normal distribution n of n mu comma sigma root n such that z is equal to Sn minus first value n mu by second value sigma root n. So this is the formula for normal distribution. Where Sn is sum of n random variables. Okay. So now, what is the first question here? The first question is estimate the probability that first 100 customers spend a total of more than 840. So first 100 customers. So this is Sn. Sn is first 100 customers. Sum of n 100 customers. N customers. N is equal to 100. Okay. So we have to find out Sn more than 840. So greater than 840. So this is we have to find out. Probability of we have to find out this. Okay. So now in this problem, when Sn is equal to 840, what is Z? Okay, so this is we have to find out. So when Sn is equal to 840, substitute here. So 840 minus n mu. So this is also we can simplify. Sn minus n mu. What is n? N is 100. Mu is equal to 8 into 100, 800 by sigma root n. Sigma is 2, root n is 100, n is 100. Substitute root of 100 is 10, 10 into 2, 20. Okay, so now I want to find out Z value when Sn is equal to 840. Substitute Sn value 840 minus 800 whole divided by 20. So use your calculator. 840 minus 800 is 40. 40 by 20 is 2. So Z is equal to 2. When Sn is equal to 840, Z equal to 2. Okay. So I want to find out probability of the question is probability of first 100 customer, that is SN, is more than 840. So this is I want to find out. So correspondingly P of SN corresponding value is Z. So Z greater than 2. So this is I want to find out. By the normal distribution we have to form a diagram. From the diagram we can calculate P of X Z greater than 2. So for this I am going to draw normal distribution diagram. So this is normal curve. This is normal curve. This is Z equal to 0. Okay. So here they are given Z2. So 2 is possibly this side. So this is Z equal to 2. But I want to calculate Z is greater than 2. So where is the region Z greater than 2? Z greater than 2 is fully here. Okay, so these are all greater than 2. Okay, so I want to find out the shaded region. What is the shaded region? From the diagram, the shaded region is half of the diagram minus unshaded region. Are you clear? Half of the diagram. So that is half of the value is, you see the value area of the full diagram is 1. Area of the diagram is 0.5. So 0.5 minus unshaded area is shaded area region we will get. So unshaded area is 0 to 2. So P of 0 less than Z less than 2. Okay. So 0.5 minus this is shaded region. Are you clear? The area of the shaded region is 0.5 minus unshaded region. So this is we are getting shaded region. Okay. So now after this 0.5 minus from the normal distribution table, from the table the value of 2 is 0.4772. So subtract these two, we will get 0.0228. So this is the value probability of SN greater than 840. So the first problem over. Okay, second question is P of 780 less than some 100 random variable less than 820. So that means I want to find out between 780 and 820. So this is I want to find out. Okay. So here when Sn is equal to 780, Z equal to what? So we have a formula Sn minus 800. Already we wrote the formula. This is Sn Z equal to Sn value 840 minus Sn value Sn minus 800 by 20. Here Sn is 780. So 780 Sn minus mu is 800 divided by n mu divided by sigma root n. Sigma root n is 20. Already we found this. So 780 minus 800 is minus 20. Minus 20 by 20 is minus 1. Okay. So next another one, when Sn is equal to 820, Z is equal to 820 minus 800 divided by 20. So 820 minus 800 is 20. 20 by 20 is 1. Okay. So I want to find out probability between 780 less than Sn less than 820. So corresponding Sn corresponding value is Z. Okay. So in converting 720 in terms of Z is minus 1, less than for Sn you have to write Z because converted into in terms of Z value, less than 820 correspondingly plus 1. Okay, so from this I want to again draw a normal distribution table. So the normal distribution table is normal curve. The normal curve is, this is normal curve. So this is Z equal to 0. This side Z equal to minus 1. This side Z equal to plus 1. I want to find out between these two. So this is the region I want to find out. But you see, negative to positive, minus 1 to plus 1, this can be written as 2 times of 0 to 1 because both sides are symmetric. So that you can find out 0 to 1 and multiply with 2. So minus 1 to plus 1 is 2 times of 0 to 1. 2 times of 0 to 1. Okay, so that it is 2 times of P of 0 less than Z less than 1. So 2 into, this is from the normal distribution table, you can calculate the value is 0.3413. So multiply these two, the value is 0.6826. So this is our required value.